Hi, 7th graders. Mr. Ron Hobby. It's November 6th today, and here's what we did in class. You did your warm-up. You got new seats. You got your continental drift essay tests back, and you did part 1 of seafloor spreading. It says November 7th because I am getting ready for tomorrow. So that's for 8A. It's November 6th today. So your notebook entry was called a seafloor spreading model on page 14. Your essential question was, how can continents drift? And this is a missing piece to Alfred Wegener's puzzle. So if you recall, he had lots of evidence for the theory of continental drift. The problem was he could not explain how the continents moved, or what the force was that pushed and pulled them. And so seafloor spreading helped out a lot with that, as you saw today in class 8A. We did just a very simple model. Really more importantly was this background information here. And so students read through the background info in pairs, followed a very quick procedure, made a simple model, and then worked on the conclusion questions in the notebook. So we talked through these together a little bit, and students asked me questions on the side if they had them. And really you should have a picture of what the theory of seafloor spreading is and what some of the evidence is to support it. We'll do part 2 of this in class next time, so you should understand it a lot better after that. So we did the activity. You looked at an animation. Look like this, so you can see the mid-ocean ridge, and down here is molten hot magma, and as it rises up through the cracks in the mid-ocean ridge, it meets the cool salt water, and it solidifies, and then according to the theory, it solidifies here and then pushes rock away from the mid-ocean ridge towards the coastlines. So as you go out to the side of this animation, the rock is older, and the rock is the youngest in the center. And that is what your model is supposed to show you. You had a color-coded version of this, but you could see the youngest rock here in the center, and that would represent the mid-ocean ridge. Then it would spread across the seafloor and descend into a deep ocean trench, where it's recycled back into the mantle. So the rock here is now melted. It doesn't exist anymore. This part would be the oldest in this picture, and it gets younger as you go towards the mid-ocean ridge, and this would be the very youngest rock right here. So that's kind of the point of today. There was no homework. There'll be a quick 10-question or so multiple choice test next week on seafloor spreading, and then we'll move on to plate tectonics. So that's it for today. Have a good night, everybody. Bye.